Hi, this is my PV system design tool. So I'll give you a quick run through what's going on here. So this is the load profile input screen. You can see here that some boxes are coloured blue and some are coloured white. That's simply so you can tell apart input and calculation boxes. So the white boxes are where the user would input data, and the blue box are where the tool calculates the data for you. So I'll give you a quick example. So if you were to put in a lamp in here, and just say you're giving it a rating of DC, you need to make sure you use capital letters there, and so that this statement works over here properly. So that's blue, so you wouldn't touch that one. And DC, so we'll say a rating of 24 volts, and we'll say just 11 watt rating, and we'll say that is 2 lamps. So you can see here that the system's then calculated. You get 2 lamps at 11 watts, so it's calculated total power to 22 watts. And this column here is used for the inverter rating, so you can see because it was DC input here that there's no AC power here, but if you were to change that to AC, that then recalculates that to 22 watts as well, but we'll leave it in DC for now. And then just say you were to input 4 hours use and 5 days. The system then calculates how much DC power or DC energy in kilowatt hours is needed, and again AC there, which is 0 because we put a DC in over here, and it gives you your weekly energy output and your weekly energy demand and your monthly energy demand here, and down the bottom here it gives your total energy demand of the system based on this load profile. So we'll just take that back out there, so that we're sticking with the design specification which has already been inputted. There's some comment boxes here just highlighting the AC capital letters and DC and capital letters has to be used. Again, comment box just saying not to write on the blue boxes, as that's your formula bar, and white cells are for user inputs. So the next part of the design tool we'll look at is the user input, and it's designed so that it's a GUI. So just say we've got 5 boxes here, one for inverter information, one for system specifications, one for environmental data, one for module specifications, and one for battery specification. And when you click on one of these boxes, a wee pop-up should appear. I'll close this just now just to show you this next sheet. So you've got, when you click on one of these boxes, input your data, it changes each one of these. So just say we were to change, what we'll do first, the battery specifications, that's 12 volts, 130 amp hours. So if we were to click on battery specifications here, and we'll change that to 13 volt terminal voltage, we'll say 120, it was 130 amp hours, and we'll change it to say 50%, and do your percentage sign there, and we'll do 80% again for efficiency, just so you can see that it changes. Hit enter, so that applies that data, then hit your close button here, and if you go over to the next tab along the bottom here, you can see that your terminal voltage changed to 13 volts, ampere rating's changed to 120, maximum depth of discharge has changed, and so is your efficiency. Well, that stayed the same because we input it the same. The other option is to actually just change it in this sheet here, so we'll change them back to the user specifications. There we go. Right, so you could do that for each of them, and that's how the GUI works. It basically updates each of these, and then calculations are done in this sheet here. So your first step when you're doing your system design is your load profile back here, and then on your calculations, step 2, daily energy requirements. It does all these calculations for you. Step 3, daily charge requirements. Step 4, batteries. and so on. So it follows through each of these steps for you and does all the calculations automatically, and the system fully updates depending on what you input in the user input and the input low profile. And this, if you go along to Solar Display Sheet along the bottom tab here, it takes you to this screen here, and this is a sort of circuit diagram type visual output. So you've got your charge controller, which acts as the bus bar. We've got your charge controller rating here, and then it displays all your PV ratings here, including your PV array power, array voltage, how many panels are in series, how many are in parallel, each module voltage and your module power. Then when you follow that down, it gives you your circuit protection rating. So that's a minimum of 29.26 amps. So you'd probably just go for 30 or whatever the next fuse size up is from that. And then your charge control rating is 30 amps, so that rating should really get rounded up to 30 amps. And then next part is your battery bank outputs. So you've got a 12 volt rating there. You need 2 batteries in series and 3 in parallel, and a capacity of 373 amperes. There's also a part here that says if you have got above 2 in parallel, it'll come up with this part saying use larger capacity if possible, and that just keeps the number of parallel branches down. Because we were specified 130, we would need 3 parallel branches to reach our required capacity. So next we have our AC loads, which were 240 watts. So that's what this wee column was for here. So back to our display sheet, which means when you just use a round up, you're going to get an inverter probably of around 300 watts, and that should do you for the maximum AC demand that you've got there. And you want a 24 volt inverter, which inverts up to your mains rating 230, 240 volts, and you've got your fuse here, which is based on the minimum cable current rating, just to stop any nuisance tripping there. And this is our additional part here. It wasn't in the specifications, but we have added in your minimum cable sizes, and it gives you in cross-sectional area in millimeters squared, and just tells you your cable lengths there, which are input by the user. And then down the bottom here, you've got your estimated load energy, system energy requirements, and daily system charge requirements. So that is all your tabs. For the user, they should only really need to see the 4 that I've just highlighted there. So what you can do is you click on the calculations tab, right click, and then hide it, because you don't really want anybody changing any of the calculations. So if it's hidden, then yeah, it won't get ruined, and your tool will stay doing all the calculations as you've designed it to.